Understanding the elements of the periodic table is essential to unlocking the patterns seen in both nature and in science labs throughout the world. When John Newlands organized the first 56 elements known to scientists in 1863, he separated and grouped the elements based upon their atom structure. These patterns in atom structure are established by scientists after painstaking effort and commitment to understanding how these known elements exist in nature. In 1869, Dmitri Mendeleev used the atomic mass of elements to organize what we now know as the periodic table. Gaps existed for future exploration and identification of new elements. At the time the periodic table was established, only 63 elements were known and categorized by their atomic weights and similar properties. The number of elements known has grown over time as scientists focus on filling in the gaps in Mendeleev's organized structure of elements. Elements such as minerals, essential to body health, precious metals. All matter is composed of the chemical elements on the periodic table. Today, scientists are hard at work looking for additional elements to add to the empty sections. For example, the 7th row of the periodic table consists of elements not found in nature. These synthetic elements can only be created in a lab. Superheavy elements comprised more than 104 protons and are created by using particle accelerators that shoot beams of nuclei at heavier target nuclei. This creates new elements by adding protons to a pre-existing element. Creating the bigger picture with superheavy elements requires the utmost patience and steadfast dedication. The painstaking process can take years to create a reaction that lasts less than a second. Take for instance the newly added element nihonium. It took Japanese researchers 7 years to search for and compose data that conclusively identifies the existence of this superheavy element. According to the International Union of Pure and Applied Chemistry, the organization responsible for confirming the discovery of new elements, any new element must be named using a mineral, a geographic region, a mythological concept or character, a scientist, or the property of the discovered element. Since element 113 was the first found in Asia, specifically Japan, it was named nihonium after the word Nippon, which translates to Japan. Element 115 was named Moscovium to honor the Russian capital, Moscow, while element 117 was named Tennessine in tribute to the state of Tennessee because of its rich history of research in chemistry and elements. Historically, this is only the second element to be named for a U.S. state. The first was element 98, californium. Last to round out the new group of elements is element 118, oganesson, named after 83-year-old Russian physicist Yuri Oganesson, co-discoverer of the heaviest elements found on the periodic table. He is also credited with the discovery of element 114, flerovium. Since Oganessian is still alive, this marks only the second time in the periodic table's history that an element was named for a living scientist and the first noble gas named for a person. It is also important to understand how certain elements have played a significant role in ancient and present times. For instance, precious metals such as gold, silver, and copper were instrumental in the development of ancient civilizations and still remain a prevalent influence in industries throughout the world today. Each of these precious metals has its own distinct atomic mass and composition. Gold is mined from the earth for its malleability, physical beauty, and resistance to corrosion. This element symbol of power, beauty, purity, and accomplishment created a prominent status in society dating back to the ancient Egyptians. Although there are industrial applications, today the use of gold is primarily for jewelry, a whopping 78% of the gold consumed each year. However, industries rich in technology, medical advancements, and aerospace continue to use gold for a vast array of purposes. For example, gold is a highly effective conductor of electricity without the capacity to tarnish, making this precious metal an essential component of sophisticated electronic devices such as phones, calculators, and GPS units. Interestingly, included in the 1 billion cell phones produced each year, most contain about 50 cents worth of gold. Equally important is the precious metal silver. While considered secondary to gold, this metal is just as influential in its uses. Silver mining first began in Turkey and Greece around 3000 BC. Ancient civilization used silver for the same purposes as gold: jewelry, utensils, and everyday life necessities. However, as time went on, it was discovered that silver had its own unique uses. For instance, silver is a natural reflector of visible light. Because of this, silver was used abundantly in early photography. In 2003, it was reported that 1,920 metric tons of silver were used to make photos. In 2000, 1 million ounces of silver were used in the solar industry. By 2008, that number jumped to 19 million ounces as the demand increased for solar panels and other renewable energy sources. In the medical field, a natural antimicrobial, silver plays a pivotal role in disabling the metabolism of germs. For example, pioneers would place a silver dollar inside milk bottles to prevent the spread of bad bacteria, something at the time that could kill a person. Today, silver is embedded in bandages and antibiotic cream to help the healing process of burn victims. Unlike gold and silver, copper is extracted and refined from oxide and sulfide ores rather than naturally occurring in a ready-to-use state. The first metal ever manipulated by humans, copper is important throughout the world, ranking third in the most consumed industrial metal, directly following iron and aluminum. In about 4500 BC, civilizations figured out how to smelt copper by the act of heating and melting until the Bronze Age, where various ancient peoples learned how to create a copper alloy by adding tin. Today, a large portion of copper production comes from recycled source materials. Globally, recycled copper accounts for 20% of the annual supply. In the United States alone, recycled copper comprises 32%. Copper, much like silver, exhibits antimicrobial properties to kill microbes responsible for infectious diseases contracted during hospital stays. One study tested whether copper surfaces made a difference in the amount of microbial burden that causes antibiotic-resistant infections like MRSA. Without changing conditions such as hand washing and regular room cleaning, surfaces in an intensive care unit were altered to copper surfaces. The result? A decrease in infections contracted by the patients. Healthcare is not the only industry to use copper. Copper is used in building construction, electronic product manufacturing, and power generation. Copper wiring and plumbing in appliances and heating and cooling systems are used each day in homes and businesses. Copper is also an integral component in cars and trucks, from motors, wiring, radiators, and connectors to brakes and bearings. There are a variety of careers you can pursue if you have a solid understanding of the elements, including engineering, with a specialty in biochemical to chemical to biomedical applications. A biochemical engineer conducts studies on cells, proteins, and other biological substances and must develop and conduct experiments to observe interactions between raw materials, develop processes for building new compounds from these materials for mass production to the general public. For example, items created by a biochemical engineer include agricultural chemicals used to treat and develop foods for public consumption. Biomedical engineers design and create equipment and software by combining engineering principles with medical and biological sciences. Most biomedical engineers work in research facilities of companies, hospitals, and manufacturing corporations. The same holds true for chemical engineering careers. This sector is dedicated to utilizing chemistry to overcome challenges in manufacturing, food processing, microelectronics, and environmental health and safety industries, just to name a few. Chemical engineers rely on and apply engineering knowledge to develop solutions to issues that surround us every day, such as pollution control and making energy sources more productive for future generations. Materials scientists examine the chemical properties of metals. You could work for companies that make products from superconducting materials to integrated circuit chips and fuel cells. While researchers are hard at work discovering new elements, it is important to realize that the periodic table remains a true testament to the skill and dedication of scientists throughout the world. For an excellent interactive version of the periodic table of the elements, please visit www.ptable.com.